we had talked about those first three sections, 7.1, 7.2, 7.3, and I'd asked you guys to start working on the 1 through 22 and the worksheet 1. Let's start with some questions from that stuff, if there is any. Wow, today. Katie. Sure. You said 6? Yeah. Sure. So here we're just determining whether we have 0, 1, or 2 triangles. So I'll start by drawing my picture. And labeling it. So, what scenario are we in here? Correct. So this is the SSA case. So the first thing we need to check in the SSA case is the size of that angle that's given. Is that angle acute, right, or obtuse? Okay. So in the acute angle situation, we can have 0, 1, or 2 triangles still possible. What we need to check is the relationship between the side opposite the given angle, that's B, and the other side that's given, that's A. So is B smaller than A, equal to A, or bigger than A? Smaller. So this is the situation where it's totally ambiguous. Any other scenario with the relating to A and B, it's one triangle and done. This is the situation where we need to analyze this a little bit better, or a little bit more. So to do that, we're going to take the bigger side, multiply it by sine of the given angle, and divide it by the shorter side. And we need to look at the value of this number, because that value of this number is going to tell us what's going on. So 13 sine 87 divided by 4. That number is 325-ish. And since that number is greater than 1, it tells us no triangles are possible. If that number was equal to exactly 1, one triangle is possible. If that number was less than 1, 2 triangles are possible. You're welcome. Yeah, Natalie. Sure, that's in the same section, right? Okay. So again, draw and label my triangle. At this point, you guys probably have realized that nothing I'm drawing here is to scale, but that's fine. It's not, the point of this isn't to draw an accurate picture, it's just to get an idea of what's going on. So Natalie, what situation are we in? Very good. If I look at the given angle, is that acute, right, or obtuse? Okay. So next thing we do is we want to analyze the side opposite the given angle, that's x, with the other side that's given. Is x bigger, equal to, or smaller than y? Okay. That's what should happen since x is the biggest angle. The side x needs to be the biggest side, which is what's going on right here, right? So that just tells me it's one triangle. And I'm done. No extra analysis needed. The only time we need to do that extra analysis is in an acute situation or the opposite side is the shorter. So in the case of a right triangle or an obtuse triangle, all we need to do is check to make sure the side opposite is the bigger side. As long as it is, we have one triangle. Otherwise, no triangle is possible because the hypotenuse would be the longest side, which is a problem. Anthony? Sure. So 11, we're told that it is a two triangle situation. So I'm going to dive straight into the solving part, since we know that two triangles are possible, right? So I'm going to make a place to record my answers for triangle 1 and triangle 2. Because again, from my experience as the math teacher in the room, one of the most common things students struggle with here is just like information management, and it's keeping track of the values and making sure we're using the right information in the right situation. So I'm going to label the unknowns with subscripts 1 and 2 to indicate that they belong to triangles 1 or 2. But the given information that we start with is a part of both triangles, so I can use it in either context. And then I'm going to make a space where I'm going to do all my work for triangle 1 and a space where I'm going to do all my work for triangle 2. So it's trying to keep track of things so I don't get put the wrong stuff in the wrong spot or whatever. You know what I mean? Okay. So in triangle 1, I'm just going to treat this like a normal law of sines problem. So I have an angle and a side opposite it. So I'm going to start with sine 64 over 16, and I have an angle that I don't know, but I know the side opposite it. So I'm going to say that's equal to sine b over 17. I'll cross multiply, so I get 16 times sine, really b1, equals 17 sine 64. I'll divide both sides by 16. And then to get rid of the sine in front of the b1, we use sine inverse So I'll go to my calculator here. So that gives me 7274. Look good? Now that I know two of the three angles, I can solve for the other angle really easily. So 4326 and now that I know one of either angle C1 or side C1, I can use the law of sines to solve for the other piece. So again, I'll start over. Sine 64 over 16 equals sine of angle C1 over side C1. And then I'll cross multiply and divide by 16. I'm going to skip some of the work there. Is that okay, Anthony? Okay. I'm just going to write down what I'm going to be typing into my calculator. We've done that algebra a bunch of times, so I think that's probably safe for me to do. But if you objected, I would have written it all out and done the extra steps or whatever. But so that's 1220. Back down there, some people are probably still writing. Okay, so we still have to do the stuff for triangle 2. Now, triangle 2 is nice in that it's a little bit less work than triangle 1. So in triangle 1, we had to use the law of sines twice. In triangle 2, we only need to use the law of sines once. So that's nice. So the first thing I'm going to do is solve for one of the two angles. Since I solved for angle B1 first in triangle 1, I have to solve triangle 2 in the same order. So I have to find angle B2 next. That's a common mistake I'll see students make, is they change the order they look for things in triangle 2, and that's not okay to do. So to get angle B2, I have to find the complement of angle B1, or the supplement of angle B1. That'll always be the case. But again, remember, we have to do this triangle 2 in the same order that we did triangle 1. So we have to find angle B1 first. We can't find, or I'm sorry, angle B2 first. We can't start by finding C2 first. So 107.26. God bless you. Yep. Now to find C2, that's easy because we have the other two angles. So far, so good? Okay. Oh, shoot. 64. So 874. And then to find side C1, I can do the same thing I did, or I'm sorry, to find side C2, I can do the same thing I did to find side C1, except instead of using angle C1, I'm using angle C2. I'll cross multiply and then divide by 16. I'm sorry, I meant by, we're dividing by sine 64. And then it's calculator time. Again, I skipped the cross multiply and divide step, right? Or showing the work for that. But it seemed like we were good there. So I get 271. feel okay there? Yep. Again, the place where students get stuck is typically remembering that supplementary relationship. And the place where they often make mistakes is they change the order in which they're looking for things in triangle 1 and triangle 2. So remember, triangle 2, you have to do things in the same order that you did triangle 1. Mostly that applies to which one you're finding the supplement of. If you found the supplement of angle C1, that's going to give you the wrong answers. And I don't think that was something I emphasized enough of. I think we did the same order when we did the example, but I didn't expressly say that you have to do that in the same order for triangle 2 as you did for triangle 1. So I'm glad you asked about that. We could get a chance to make sure to emphasize that point. These are the little things that, like, as a math teacher, you take for granted that people are going to do that, like, maybe I need to make sure I say that. After, a day and a half later and somebody else asks the question, you're like, oh yeah, well, we need to make sure, that's what we did. We didn't say that we're doing it, have to do it that way, but have to do it that way. Who's next? Yeah, I can't see. Alexis.
Oh, can you do numbers?
But you're not Alexis. You're Alexandria.
Yeah.
Yeah. My apologies. Number 3, you say?
Yeah.
Sure. Okay. It says basically we're just solving these. So I'm going to start by drawing my picture. So if I look at my picture, which situation are we in? That's incorrect. This is side angle side. Again, I can tell that because the two sides make up that given angle, right? And the side angle, one of the sides is not part of the given angle. So here we should be using the law of cosines. So if I look at the law of cosines, the only thing that I can solve for, the only thing I have enough information to solve for is this side Q. In the side angle side situation, you're always going to be finding that missing side length first. Oh, let's write down, put the numbers in. So we'll say that Q squared is equal to P squared plus R squared minus 2PR times cosine of Q. But I don't want Q squared, I want Q. So I'll just square root both sides. So I'll type all that mumbo jumbo into my calculator. Alexandria. Is that okay so far?
Yeah.
Okay. Holler at me if I go too fast or I do something you don't like or I skip some step. You're like, wait a minute, why are we doing this again? Okay, so again, so 2259 is what we get there. Okay, so now I'm going to use the law of sines to either solve for angle P or angle R. Does it make a difference which one I do first? Yes, if we want to keep our life simple, because I'm a simple guy, I like a simple life, right? My life's complicated enough. I don't need to make my math more complicated. To keep things as least complicated as possible, I want to find the smaller of those two angles first, but I don't know what either of them is. How do I know which one is smaller? Look at the opposite side lengths, man. Right? Side lengths and angle measures are proportional. So which side length is smaller, P or Q, P or R? P. So that's the angle I'm going to find first. Sound good? Okay. So I'm going to have side P squared equals Q squared plus R squared minus 2 times Q times R times cosine of P. Feel okay? Okay. To solve for P, I'm going to go and subtract the 22.59 squared from both sides, and then subtract the 20 squared from both sides. Then I'm going to divide by the negative 2 times 22.59 times 20, and then take the cosine inverse of everything. And that'll give me my P. Alexandria. Did you follow the algebra that we did there? Yeah. I did it all kind of in one step. I just want to make sure that we're doing okay. Everybody, anybody else? Problem with the algebra that we just did there? Okay. If you change your mind, let me know. So when I do that, I get 5652. And then now that I know two of the three sides, getting the, or two of the three angles, yay. Getting the third angle is real easy. So 3748. Alyssa.
So when can you, so for those problems, like I think I ended up messing up because I did for the second part, finding the angle
You did R first?
I did I did R first, but I used like the sine one, and they gave me a different number. So like even though you had Q angle and Q side, you still
yeah, I could have done. I said I was going to do the law of sines there, and I just didn't, huh? Let's just verify that that does indeed give me the same thing. That's a good point. Thank you, Alyssa. What's up? I have a different answer in the key also. Oh, Boise. Oh, yeah, of course I would, because that's not the way we're supposed to do things with the law of cosines. We're supposed to find the... Yeah, we're supposed to do this.
So confused.
Yeah. I wish that when I start doing something wrong and you know I'm doing something wrong, you're like...
I just never know if I say something. I'm like, so much smarter than I am.
It only looks that way on the surface. Well, here's the thing. You asking a question, be like, hey, aren't you supposed to do this rather than this? like, just if, like, say for instance that I am like that much smarter than you,
Oh, just like.
like, I don't know why this is being such a, oh my God, I hate you so much, computer. You asking, I can't stand this. I don't know why. How am I supposed to get rid of this thing now? You asking a question about something. Oh my goodness. Computer, I'm going to throw you out the window. Sorry. I'm just trying to get rid of this stupid 8, and it's like, I really want this 8 to be here. All right. One note. You asking a question like that, though, like, doesn't, like, me being better at math than you asking a clarification question like, hey, aren't I supposed to do it this way? I am certainly capable of making mistakes, like, and the fact that you think I'm doing it wrong should be a reason to ask a question, because it's at least like, hey, am I thinking of this the wrong way? Like, I want to make sure I'm not. Like, that doesn't, like, you ask that question. You should stop me and ask that question. Yeah, I'm just saying, like, I'm not trying to poo-poo on anybody, like, oh, you guys should have stopped me. But I'm just, like, letting you know that, like, if I'm doing something, you think I'm doing something wrong, you should stop me and say something, because either I am or you've got something the wrong way going on remembered. Either way, we need to fix that, right? Yeah. Perfectly reasonable thing to do. Now, I might make some faces at you if we've, like, said why I was doing something immediately before doing it, and you're like, hey, why are we doing it this way? And it's like, well, I just said that. I might make a face about it, but I'll still repeat myself and say that, like, okay, you know, like, it's fine. Anyways, I'm totally losing track of where I'm at because I've gotten down the rabbit hole here. All right, so let's see. We cross multiply, divide by 2259, and then do the sign inverse. So this is what I'm typing into my calculator. Where did I, jeepers creepers, Kulik. I have had, like, such a headache all day today, and I've just been, like, stumbling through all of my classes, and it's not been a great day for the old, for old Mr. Kulik. Alexandria, are you okay with the mistake that I made, why it was a mistake, and what I'm doing now differently?
Yeah.
Okay. My apologies. Again, these are good. This is good though, right? It, like, forces us to talk about, like, why things are a problem and all of that, right? So 3199 seems better. So that gives me 62. Oh, I guess that's really 32 even, huh? If I rounded that the right way. Let's round it the right way. Okay. Okay. Alexandria. Does it feel okay now that we did it the right way?
Yeah.
Okay. And you're okay with why the previous way, what I did the first time was wrong?
Yeah.
And what I did the second way was right?
Yeah.
Okay. Does everybody else catch what the mistake that I made? It's an easy one to do. Like, don't be dumb. Mr. Kulik was dumb. You know? I make mistakes, guys. It happens. You guys get it. You've made a mistake. Everybody does it. My apologies.
I'm actually a genius at that.
I'm a genius at making mistakes, so take that.
Is it cool if you see my test scores so high?
You're like, I think I got you beat.
I definitely have you.
This is fun, guys. All right. Who's next? Maddie.
Can you do number 6 on worksheet 1, please?
Sure. All right. All right. Start by drawing my picture. Okay. First thing I need to do is identify the situation. This is side angle. Okay. When I do a side angle, the first thing I need to do is check the size of the given angle. Is angle X acute, right, or obtuse? Acute. So in the acute situation, either I have the 1 triangle scenario or the 0, 1, and 2 triangle scenario. To tell the difference between those two, I need to compare the two given sides. Basically, what I need to do is look at the side opposite my given angle, that's side X, and compare it to the other given side, that's side Z. What's the relationship between side X and side Z?
Side X is smaller than side Z.
Very good. So that is the worst case scenario where we have 0, 1, or 2 triangles, and we need to do that additional step to confirm which one of those it is. The way we check that is we do the longer side times the given angle, or sine of the given angle, excuse me, divided by the shorter side. And we're going to analyze that number. So 0.905. So the size of that number is going to tell me how many triangles I have. So if this number is less than 1, like we have here, that tells me we're going to get 2 triangles. If the number was equal to exactly 1, that means 1 triangle. If it was bigger than 1, that would tell me 0 triangles. Oh boy, goody, it's the worst case scenario where we have the most stuff to do. So again, I'm going to make a space to record all of my answers so I don't forget to do something. So again, the givens are the same in both triangles. But we need to solve for angle Y and angle Z, and then side Y in each triangle. I'm going to add a subscript 1 for those pieces in triangle 1, and a subscript 2 for those pieces in triangle 2. Everybody good with how we set that up? Now I'm going to make a space to do the work for each one of these 2. Again, trying very hard to keep myself organized. So doing triangle 1, we're just going to set this up like a regular old law of sines problem. So I know both angle X and side X. and I know side Z, so I'm going to be able to find angle Z. I guess I really mean Z1 though, right? Maddie, so far so good? Okay. I'm going to cross multiply, then divide by 30, and then do the sine inverse of both sides. So I'm going to do all that algebra here all at once. Is that too much? Okay. Again, after you've done a couple of these problems, it's like it's the exact same algebra every time, and like, I mean, if you write down this step and this step, I'm usually pretty happy, provided you don't muck up the in-betweener, but and everybody's checking my work to make sure I didn't do what I said I didn't want to do and like screw something up, right? So 6484. Okay. So now that I know two of the three angles, getting the third angle is pretty trivial. $62.16. Everybody still doing good? Okay, and then the last step, I'm going to do the law of sines again. Now that I know angle Y, I can set up a law of sines to solve for side Y. And really, I mean angle Y1 and side Y1. But you guys got it, right? Since we're working in triangle 1. We'll go ahead and cross multiply and divide by sine 53. And then it's just my old friend calculator. Bust him out. So 3322. Maddie, so far so good? Okay. On to triangle 2. Since we solved for Z, angle Z is my first thing in triangle 1. I have to solve for angle Z2 as the first thing in triangle 2. And I remember that these angle Z's are going to be supplementary. So that's 115.16. And now to get angle Y2, again, pretty straightforward because I know two of the three angles. So 1184. And then to solve for side Y2, I'm going to set it up the exact same way as before. But instead of using angle Y1, I'm going to be using angle Y2. cross multiply, divide by sine 53. Oops. And I get 771. Feel good on that, Mads? Good. Questions for any of yous guys? Okay. We feel a little bit better about doing this. Again, it's one of these things like once you get the hang of it, they're kind of all the same. You just have to do a little bit of practice to make sure you've like run through the scenarios, but it's not so bad. All right. So let's finish out chapter 7 here today.